All right, welcome everyone. Looks like YouTube's online. All right, let's get into it. Nothing new for me here. Spectrate, you're last. Someone has an answer, as usual. Yep. Let's see. You're up to 3 now. So ever since I started keeping count, at least. It's live? Oh yeah. So I still need to make the leaderboard command, but or like you can check individual people, but I don't have a command yet to like get the top 10. Which I'm sure there's something that I can find that's like pre-made for me, but I just need to actually stop being lazy and look for it. I think last week. But I think there's 1 or 2 people who I missed by accident because this bot, it's a program you have to run on your computer, and I forgot to run it before I started the stream. At least 2 times. I think I only manually updated it once. It's not bad, yeah. This one doesn't have an answer. Type of discontinuity is shown in the following graph. Oh. Was there between a removal discontinuity and a missing point discontinuity? Maybe missing point discontinuity is if it wasn't defined at all for x equals a. It's kind of weird though. Missing point discontinuity. Okay, so it is what I guess. More beans for you, nice. No, that's a removal discontinuity what they're saying here. I think this depends on the class or like what book you're following from. Hey Scorpa. Nice emotes. Glad to have you in here. Classification of okay, let's see what Wikipedia says. Removable discontinuity, a jump discontinuity, an essential discontinuity. You can't be without this discontinuity. You need it. Okay, well that doesn't match at all with what the person has. Okay. So, we can't give this person a firm answer, I don't think. We can give them an answer, though. One of those, I think, how exactly each of these are defined depends on the professor slash textbook. So I would take a look at your note slash textbook. To see the exact definitions. My best missing point discontinuity. Discontinuity. I haven't seen before, and it seems similar to a removable discontinuity. Do I sound out discontinuity every time I say it? Let's guess at what each of these mean. Okay, removable discontinuity. Discontinuity. If a function looks like it should be continuous, but has a hole somewhere along it, you could define the function there to fill in that hole. That's what she said. Let me actually infinite discontinuity. Oh my god. Do I need to copy paste the word discontinuity just so I don't have to sound it out each time? I think that's what I have to do. Discontinuity. Jump discontinuity. Missing point discontinuity. Okay. Now let's go to the big editor. Similar, a continuous version of that function. The most common example students see is with a rational function like f of x equals x plus 2 x minus 1 over x plus 2 x minus 3, let's say. There is a removable discontinuity at x equals -2 because you could cancel the x plus 2's from the top and bottom. But f of x still isn't defined there. Okay. Infinite discontinuity. This is a vertical asymptote. To infinity, positive or negative. One over x has an infinite discontinuity at x equals 0. Jump discontinuity. Where a piecewise function jumps from one point to another. Or with a gap in between. I need to look back at the graph that this person has. So I would call this a jump discontinuity out of all of these here, because you definitely can't remove this discontinuity. It's not infinite. in a missing point discontinuity, we don't seem to be missing a point here. So call the example in this problem a jump discontinuity because of that gap between each piece of the function. Okay, missing point discontinuity. That's where I'm not sure. That's where I'm not sure. It could be an equivalent term to removable discontinuity, or it could be a jump discontinuity. Could be something like, hey Jed, discontinuity. You missed the first because your body tried to nap? Oh. I'm sorry you didn't get to actually nap then, it sounds like. Isn't defined at all at the jump. Notice in the example here, the lower part of the function has a closed dot. The lower part of the function has a closed dot at x equals a. So the function is defined at x equals a. So I wouldn't think, and I wouldn't think this is a missing point discontinuity. All right, so that's my best guess for missing point. It's kind of a weird one. I can only guess based off how it's called. So that's the best that I have for this person, I think. And Google gives like conflicting definitions, so it's hard to give a general response. This looks like a double post, but neither of them have answers, so let's see what's up with this. Oh god. This is math? Where's the numbers? It's designing a city that has to follow these rules. It has 12... Oh god, I don't know if I'm going to do this one. I'm kind of curious what it's asking, but... I don't know about this one. Transform... rotate 270 degrees. Ah, what did I do? Okay, no, I'm fine. Damn, okay. What to include in your town? 3 parallel streets, 1 transversal street. Oh, it's like geometry, but they're trying to make it apply to an actual situation. Okay, there will be 3 houses. 1 house will be on the exterior of the parallel lines. The other 2 houses will be 3 houses total? Oh, no, okay. Just, wait. No, 3 houses total. Oh, there's gonna be other types of buildings. Oh my god. Okay. The exterior of the parallel lines and the other 2 houses will be on the interior of the parallel lines. That feels a little bit ambiguously put, but okay. The houses on the interior are adjacent angles. I think this person did have a house there for an adjacent angle. Oh my god. The house and a restaurant are alternate exterior angles. Well, yeah, but it's just like you could also interpret it as pairs of like parallel lines, I guess. That's where my mind goes. But alternate exterior angles. I assume that's like alternate exterior. I assume that means that like one is up here, one is down there, or well, I guess they did it with the restaurant there and the house there. Okay. They say the house, they don't say which house. I guess that is the exterior house. The school and library are alternate interior angles. They haven't placed the library yet, it seems. It's a vertical angle? I mean, I assume they mean like on the same like column, but I don't know that. The angles that lie opposite to each other when two lines... Really? Oh... I guess so. AOD and AOD and BOC. Okay, yeah, so those 265 are vertical, I guess. Yeah. Dude, this sucks. What was the actual question? They couldn't figure out the puzzle. Okay. So what's an alternate interior angle? That's what I was thinking. Alternate interior angle. Okay, so that X and Y are alternate interior angles, I guess. Yeah, this is going to take a long time. I don't know if I want to do this one. Maybe I'll keep it open, but like, it's such a pain. If I can't find another one, then I guess I'll like just dive in and try to... Oh, they triple posted this? Well, now I'm wondering if they got an answer from somewhere else, and that I'd be wasting my time if I went through the effort of solving this and writing a response. They probably posted it in a lot of different places. Let's see if we happen to spot it in a different subreddit. The 12 corner is A through L to find the terms. Oh, they are almost like making it like a Sudoku. Which is probably like the good like systematic way to like solve it. Oh God, no. I just want to see if this person, like, I'm supposed to, like, ask math or something. They already have an answer. Maybe not. Okay, there actually is very few questions out here anyway. I guess we can... I'm gonna click on this person's profile quick and just see if they posted it somewhere else. They did. All right, well, I guess that's... This person has... Oh, no, this is, like, a tablet. That's not actual handwriting. I mean, it's still nice handwriting, though. I was amazed that they, like, freehand drew perfectly straight lines. But I don't think they actually did. All right, so I'm glad I looked, because I didn't want to, like, put a bunch of effort into this. That's not handwriting. Could be R's in grocery. Well, I'm not saying it's typing. I'm just saying someone drew it on a tablet, like how Pen Center does whatever that program is, like OneNote. I think it's that. It is weird that some of them are different thicknesses, though. Like that R in Park is really thin. I don't know how you do that on a tablet, I guess. Library. Oh, that R, yeah, they got a little lazy on that R. Either way, I guess I don't have anything to add here because I'm not about to like go through and work this out for myself just so I can verify this. Isn't much on Reddit. Let's try Discord. Actually, wait, I want to check one thing on my Discord. Okay, cool. Oh yeah, Jay, that's just like a... That's actually what I was checking. I realized that I didn't check the timestamp that I made. Oh wait, you meant for for Phasmophobia. Okay, yeah. Hey, Anders. Yeah, it's looking like there isn't going to be a ton of math for me to do today, so I'm probably just going to get to the 2-hour-ish mark and switch over. Hmm. It's going good. How about you? Math's been a little bit slow today, but we have those days. I don't understand the problem, so feel free to roast me. Okay, well, I guess let's take a look at this one. Jane is 2 miles offshore in a boat and wishes to reach a coastal village 6 miles down a straight shoreline from the point nearest the boat. She can row 5 miles per hour and can walk 4 miles per hour. Oh. Where should she land her boat to reach the village in the least amount of time? That's it. Huh. So I guess you need to compare rowing. Why isn't rowing all the way there just the answer? She rows faster and it's a shorter distance, isn't it? See, I agree with this right triangle here. You solved just before you were falling asleep at night. Oh, good. Jed, yeah, I think we're ignoring water currents. That sounds like a whole thing. Because, like, if, 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 if you were to row straight to shore and then walk, your walking is slower than your rowing. So you only get 2 miles of your fast time and then 6 miles of walking. Whereas you can just row the entire way there and you're going faster and it's a shorter distance. I don't know why you wouldn't just row. Let's calculate both scenarios. I assume it's not going to be an in-between scenario here. Like, you rather go straight to shore and walk, or you go straight to this to the village. Something that someone. Oh wait. Oh. What would that be? I don't know what this is. I don't think it's right. Hey, Bio. Went after that. Okay, this is someone else trying to help, I guess. I don't think that's a situation where this is water and the village is inland. I think the village is on the coast. A really hard irrational equation. If you want, you can post it up in my Discord. The last irrational one I tried was pretty hard, but I can at least try to get through it. Oh yeah, you can go to chat too. Yeah, exactly, Jed. I don't know why you would ever. So okay, I guess we can do this in Wolfram. We don't even need to go to the board here. So if you do square root 4 plus 36, that's the distance if you row straight to the village. And so that's the distance. You go 5 miles per hour. So you do 5 divided by this, and that's the time it takes. I think. Yeah. So basically 0.8 of an hour. Whereas if you have 2 miles of rowing, 2 divided by 5, plus 6 miles of walking, 6 divided by 4, that's like more than double the time. It's not even close. Do you have an algebra problem you'd like to show you? Oh yeah, sure. I guess Bio put their thing. Put their thing first, but I can look at that after Andres, I guess, unless yours is short. Row directly to the village. shorter distance than going to shore. Okay, always had the problem. Oh, okay, that's good then, because I'm gonna. How many real solutions are there in the set of real numbers? Yeah, I from Bio's other questions that I've seen, I think it's just get that in a vacuum, Jed. So you got x1 equals 1 and x2 equals 5. Do those both check out? If you plug x1 equals 1 in, don't you get, I guess you get 3. Yeah, you're right. Huh. So why would it only be one real... Okay, so that's how you're asking that, Jet, I guess. Wolfram Alpha also gets... 1 is not in the solution? Why not? You can literally plug in 1 and see that it works, so... Okay, I guess maybe it is what Jed's saying, where there's some kind of context for why you should eliminate that, but I feel like there probably isn't. Oh wait, is it 5 is greater than or equal to 0? It has to be a big square root to be Pythagorean, I think. X is greater than or equal to 5? Oh, so you have that domain. Yeah, so in that case, that's why you throw out x equals 1. Because 1 isn't greater than or equal to 5, so I guess you throw it out for that reason. That's kind of weird. Oh, well, yeah, it's not defined for x greater than 5. Yeah. Yeah, you're right, because you get negative numbers here. I feel like it must be a mistake. Because I don't get what she meant either, Bio. Yeah, Jed. I think I agree with that. Like the domain by default. I think from Bio's other ones, there's like an arbitrary domain that was also like defined, even though you could evaluate the function for different values. Like it's like took an equation like that and arbitrarily said, oh, 3 is less than x is less than 4 or something. Nineteenth question, I assume there's some hard logic behind it. I'm not seeing it, I'm gonna be honest. This function, it literally just is valid here. I don't know what else. Like, say here. Z, X. Why does that look different? Did I type it in wrong? 2x minus 1, 5 minus x. Oh no, okay. So yeah, when you plug in 1/2, you get 0. And then, okay, yeah, that makes sense. So yeah, 1 comma 3. I mean, I don't know. So if it's a normal, like if you're saying that 3 is the hypotenuse here, Jed, you wouldn't have these be square rooted individually. Unless you have some weird like quarter root situation and 3 is already squared. But x equals 5 is the answer, apparently. Yeah. So I'm really puzzled here, Bio. X minus 5 is greater than or equal to 0. So x minus 5 greater or equal than 0, it is the same thing if you multiply each side by -1. Maybe you know? Okay. Yeah, if you know, that'd be great, because I know I don't. I know, my thing I was about to say isn't even right. One part says 2 times root 2x minus 1 times 5 minus x is equal to x minus 5, which means x minus 5 is greater than or equal to 0. Right, if both those parts are underneath the same square root, I guess, well, I mean, that's a flaw in how the solution was obtained then. X minus 1, it just is an answer. So if what you're saying is like this, yeah, you're right. The result of a square root can't be negative. So x minus 5 would have to be positive. But 1 is still an answer to the original problem. You can plug it in and see that. Okay, so sounds good, Anders. It's like maybe you do get to this stage at some point as you solve it. That doesn't mean that 1 isn't a solution, though. It just means that you're never going to get a solution from this technique where x is less than 5. But there may be more out there that this technique is missing. I feel like the problem was flawed, Bio, I'm gonna be honest. So this probably is where that thing came from, but like 1 is literally just a correct answer. Like I don't think I can't think of a way to debate that unless you put some arbitrary restriction on it. That is what that means, Bio. But in the original problem that you were given, there was no such restriction that x is greater than or equal to 5. It's only once you get to this point in your solution that you have to realize that this particular technique will never get you an x that's less than 5. There may be one that is less than 5 out there. It does not tell you anything about that. So I assume that you did some different thing where that didn't happen, but like for this, like I don't really get why they would throw out 1. They threw out 1 as part of this, I guess, but that's not right because 1 still works. If you plug 1 even into this step, you... Oh, yeah, so 1 doesn't work here. Hey, Brian. So this question is just weird to me, Bio. I'm not sure what, like... So Bio there in chat was given this equation here to solve. The question is, how many real solutions are there? They got, to me, correctly, x equals 1 and x equals 5, so there's 2 real solutions. Apparently, the answer key says there's only 1 real solution, which is x equals 5. But I can't think of a reason why x equals 1 does not work. So that's what we've been debating. As far as I know, there isn't like an arbitrary domain restriction or something like that. Like Bio, I guess it must be that, but that's so like, that's not valid. I don't see another reason either. I don't think that is a good reason, but it's the only possible reason that I could see, but it's also just not true, as far as I know. Well, yeah, so if you get if you start with this with no domain restrictions aside from, you know, between -0.5 and between 5, if you get a domain restriction as you solve it, like in this step, it just means that your solution is not complete, or it doesn't check every possible value of x. It's like, yeah, as soon as you cross the threshold into getting to this step, you eliminate anything where x is less than 5. But as we've seen, there just is a solution that's less than 5. So I think you're right, where like that must be the reason why they're saying it's only 1 result, but I feel more like the question is wrong. Well, it still says that x equals 1 is an answer here. That's weird. Oh no, because I didn't hit enter here. Bio's answer key apparently does. If you don't move root 5 minus x to the right side of the beginning, it has no solutions. Really? So I was thinking you would multiply by the like conjugate of this, by like 2x minus 1 minus 5 minus x. It's probably better if you do move this over to the other side and square it. But see, I'm not sure what to tell you about this one. It should work both ways. Yes, I agree with that. It doesn't for some reason? I think one way is usually easier. I think it's what you said was squaring each side, but I don't have a good recollection, to be honest. And maybe some super hard, like, algebra trick, but I imagine there's a way to always do it, as long as you've done valid steps before that. Yeah, BCOR, I completely agree. So, this is a weird one. Oh gosh. I think Bio has solved the problem for themselves. Because I think they did get x equals 1 to x equals 5. It's just the answer key not reflecting that, which was the question. So when you said an algebra problem, Anders, I didn't know you meant this algebra. Let's see if we can figure this out. I say nothing about set theory, except what the subset relation is. I guess proper, well, yeah, proper subset, right? No, just regular subset. Consider an alternative definition for the union. Definition: given two sets A and B, we'll say that a set S is a union of A and B if it satisfies the following two properties. It contains both A and B. I thought it was like something that like Bio put, or just solve for X. I'm still down to try with this one. I don't know if I'll do it right. So we'll say if it satisfies the following two properties, it contains both A and B. That is, A is the subset of S and B is the subset of S. It is the smallest set with the previous property. Why would you ever get more symbols? Oh, I get it. Because just containing A and B means it could have something extra that's not in A and B. And this second condition gets rid of that. Not allowed to see what the set has inside. And, okay, so no axiom of choice, I guess. Prove the union of sets is associative. Huh. I guess let's go to the whiteboard and try to kind of draw this out and think about it. This is very far away from the kind of math that I'm usually good at, but let's see if we can figure this one out. But you already did this proof in a different context. I imagine it's going to be pretty similar to normal associative proof. I just haven't done anything like that in a long time. Okay. So, all right. If you want to show that associativity, I guess that means we need to set up, we want to show A union B parentheses union C is equal to A union parentheses B union C. Make sure I'm writing that in a not awful spot. Okay, we're good on that front. So and I guess in other words, that means that if the result of this, if we call it X and the result of that is Y, I assume we need to do something like X is a subset of Y and Y is a subset of X. Because that's how you prove that sets are equal to each other, I think. All right. So it should be one of those things where it's just, it makes sense, right? You know, do we really have to prove this? Yes? Okay, good. Contains both A and B. Is a small set with the previous property. The union of sets is associative. Okay, so I guess we would say my attempt here, I guess, is let A union B union C equal X. And then I guess we want to make some statement that I guess by definition, we can definitely say that C is a subset of X here, right? Oh my god, not equal. Right. And I guess we can say A union B is a subset of X. So I guess we should show that this implies that both A and B individually are subsets of X. That's kind of my thinking here, and then we'll do the same thing for the other side of the equality, and that can hopefully prove both directions at once. Or is there a different thing that we could do here? I mean, I'm trying to figure out how much justification we need here, but like, can I just say that, like, hence A is a subset of X and B is a subset of X, or do we need to do something like, you know, let A union B be X1 and X1 is a subset of X, and then by definition again, I don't know, I hope I wouldn't need to say all that, but I don't know. Keeps applying the second property of the definition. Okay. I guess further, breaking out all our proof words, X is the smallest set such that A is a subset of X, B is a subset of X, and C is a subset of X. And then hopefully we do the same thing with Y, or like with the other side of the equation. And this last statement is going to be the same for each of them, and that's our proof. That's my hope. Say A subset of Y. Do we know the smallest set is unique? I guess that's kind of what this technique would hinge on. Maybe we don't know that. But I feel like it... See, my idea was just to show that the smallest, they both have to be the smallest sets, such that these are all three subsets. But if we haven't proven that the smallest set is unique, then maybe that doesn't apply. Or we need something more here. Hey, Henrik. What? A few days ago, I saw a woman in the bus which looked exactly how I would imagine you would look as a woman. I wanted to ask her for a selfie and send it to you, but I didn't. Yeah, that sounds pretty freaking creepy if you asked her for a selfie, so I'm glad you didn't. Glad to know I have woman doppelgangers out there, though. But yeah, please don't harass random people in public asking them for selfies. That's not going to go well. Oops, not X. I'm just reflecting the language that I did up here because I guess, Anders, I need to ask you if, do we know that this smallest set from the second part of the definition is unique? So I think if it is, the proof is I have the idea. If it's not, then I don't know. There cannot, like this claim that I remember right here, I guess is what I'm not sure of. The two, I guess I'll say disjoint, or maybe distinct is better. No, yeah, disjoint isn't right. I guess I'll say distinct. Smallest sets, X and Y, it must be that X equals Y box. That's my idea for this proof, I guess. I didn't really do the whole subset of each in both directions, but I think it's kind of the same idea. Just I didn't have to write it out like that. So I'm not sure. I'm kind of a fish out of water with this type of algebra, but let's see what you're typing. Uniqueness is a direct consequence of the definition. You can assume that. Okay, that's what I was hoping. Like, if you can't have two small sets that are different, I would think. So I guess, do I have the right idea here, Anders, or is there a different way that I should have done it? I can get rid of my webcam again because I realize that I'm blocking it. And Henrik, you're saying z equals a plus 2i over 3 minus I squared, where a is a real number. Calculate a so that the argument of c is pi over 4. Seeing the solution is problem, you don't understand why it works. I bet you I could figure out the answer to that problem. But do you want me to go through the solution that you've seen and explain that? Or do you want to see me try to work it out? Just like independently. The right idea, but I skipped some steps. Oh, really? Ipsum Wacky Stove? Yes, this is, This is a branch of math that's called algebra, but it's not the algebra that you encounter in high school. If you go on to study math, there's a whole algebra becomes something that's very difficult, or even more difficult than what you're studying in high school. It's how I describe it is algebra is what you study if you want to invent your own types of math with their own like rules, but you do it in a consistent and rigorous way. It's not just solving for x or like 2x plus 3 equals 5. And the thing that Anders here in chat asked me to take a look at, I think just for fun, is this problem here, which is proving associativity between two sets. And you probably encountered the idea of associativity, which is just like with multiplication or addition, you're allowed to move the parentheses to two different parts. That's all associativity means. So a context you've probably seen associativity is like the idea that A plus B plus C is equal to, oops. A plus, now in parentheses, B plus C. It's like we'd say that addition is associative because it has this property. The parentheses don't, you're allowed to switch them around or even drop them if you wanted, but the order which you do the addition isn't important. And we have something called sets, which are just groups of anything, basically. And you have something called the union of two sets, which is like, you take all the elements of each set and you add them together into one big set. That's kind of the quick definition. And so it's doing the exact same thing as proving this property, but with sets in a slightly different like context, I guess. But it's the same exact idea. And I'm not good at this type of math at all, so that I tried to prove it, and apparently I have the right idea, but I skipped some steps. So I want to take what I've written there as a proof. Since there are no numbers here, yes. In the algebra that we're talking about, you don't really deal with actual numbers. You have sets and operations on those sets. Like by operations, I mean, it could be like the sets are sets of numbers. Like you could say that it's like all integers, all real numbers, all irrational numbers, and that type of stuff. And you can use algebra to define what it means to add them, multiply them, all that stuff. Oh, the music is cutting out again. That's so annoying. I don't know why it does that. I've Googled it and there's like nothing on Google. I'm just gonna pause it. Oh, it's fine now? Oh. If it is cutting out, it's not just you. I've had that complaint before and I don't know how to fix it. I'll turn it back on, but tell me if it does. So yeah, Epsilon, this is definitely not my favorite area of math, but Anders wanted me to take a look at it. So I was like, oh, why not? And Henrik, you're saying the solution you have seems to multiply the complex conjugate and set real equal to imaginary greater than 0. Yeah, okay, that's basically how I would do it. I mean, I thought of a slightly different second step, but that's the same thing. Exactly, Henrik. Pi over 4 is greater than 0. And argument is only defined for minus pi over 2 to positive pi over 2. So you don't need to do a, you don't need to worry about going past pi over 4 over to like 3 pi over 4 or something like that. So I was gonna like put it into like a exponential form and just literally have a pi over 4 in there, but what they have is the same thing. If you want to solve it to like actually go and work it out, 1 over 25, if you want to follow people on insane, 1 over 25 as a decimal, isn't that 0.4? Or sorry, 0.04. Yeah, 0.04, right? 125 over base 6? Oh no. Okay. Is that the follow-up? I mean, we could convert it to base 10 and do that math, I guess. 1 is still 1, thankfully. 25 is going to be 5 plus 36. Or 2, no, plus 5 times 5. Wait, 6 to the 0, 6 to the 1. So 5 plus 2 times 6 is 17. So it's 1 over 17? You want the answer in base 6? Oh, no. How do you do math in base 6? Or how do you do, like, division in base 6, I guess? Do we... Okay, maybe I can figure this out. I've not done... I mean, I learned, like, binary and how to do stuff with that, but, Oh, shoot, and Henrik, I'm happy to actually, like, work out that problem, too, and show you... Explain a bit more on why that step is the way that it is. Just, like, let me know if the little, like, verbal explanation that I gave was enough, or if you want to see me actually go and do it. Because I'm happy to do that, too, but if you already understand it, then I don't want to... waste your time explaining something that you already understand. And Anders, if there's a solution like written out to that problem, I'd be interested in looking at it to see what I skipped. And if not, it's all good, but... Okay, so how do you do division in base 6? 1 in base 6 over 25 in base 6. So I guess you do 25 like that, then like that. Oh god, this is so hard to think about. Is it still 4? Because this is like base 6, 100. Which means that 6 squared is 36, and that's 17. No, maybe it's probably not 4. That doesn't make sense. No. No. I don't know, dude. I thought I'd be able to figure it out if I drew it out like this, but I don't know. Yeah, I don't know how you do division in base 6. I'm gonna be honest. You mean in your right? All right. Oh, you're just being silly. Okay. All right. So yeah, Henrik, let's go through your problem. I'll be happy to explain it more. So let me scroll up and look at your thing. The original problem, z equals a plus 2i over 3 minus I squared. And arg of z equals pi over 4. Okay. So, I'm not the expert on complex variables, but the way that I see to do this is you want to multiply out the squared first, because we want to get rid of this denominator and The quickest way I see to do it is square it and then multiplying by the conjugate. So I guess let's do that. You get 9 minus 6i minus I. You get minus I times minus I. This always trips me up with complex numbers. So that's gonna be plus I squared, which comes back around to minus 1. Right, okay, I think that's right. The minus 1 rather than a plus 1 there. So you get a plus 2i equals 9 minus 1 is 8 minus 6i. Now we multiply by the conjugate. 8 plus 6i. So that's going to be 64. And then minus 6i times plus 6i. Then the I squared, so you get another plus 36. And then this 8a, I'm just going to do this the old-fashioned way. 6ai plus 16. Oh, not ai, just I. Minus 12 to get I times I. So you have 100 on the bottom, annoyingly. Combine the real and imaginary, I guess. So you get 8a, or the real with the real, imaginary with the imaginary. So real part, 6a plus 16i, all over 100. All right. That's an annoying 100 to have there. Let me just check because it's been a minute. Okay, nothing new. We can cancel out. The best we can do is a 2. Let's cancel that 2. For 50. All right, so, I mean, the 50, it actually won't really matter for this next part. So, if something has an angle in argument of pi over 4, it means on our axes that, it must be this like straight line, almost like y equals x, although, you know, this isn't a basic algebra class. But basically, on the unit circle, x and y are equal here. So like this length here is equal to that length there. That's what the argument pi over 4 means, because it's just like root 2 over 2 comma root 2 over 2 on the unit circle. And so that's why we know that the real part must equal the imaginary part, because on the unit circle, these two equal each other when pi over 4 is the angle. So it's like a nice little like trick you can do. I think there's a more general way that you can solve the problem too. But in this particular problem, we can take the real equal to the imaginary here. And we can set them both greater than 0 because this is pi over 4 is in the first quadrant, so both components must be positive. So the real is 4a minus 6 over 50. The imaginary is 3a plus 8 over 50. So like that right there is why you're allowed to do this step here. I can show the different way to do it too, but we'll see this through to the end. Multiply each side by 50, you get 4a minus 6 equals 3a plus 8. Subtract the 3 over, you get a equals 14. Probably about right. Yo, Ben. Gotcha. All right, glad to hear. I'm kind of curious to investigate if you didn't have an angle pi over 4. Like, we'll still use an angle pi over 4, but I was thinking you would think about the exponential form. like set it equal to this. We don't know what the radius is though, do we? So I don't know if this is actually the right way now that I think about it. There probably is a way. Let me. Because I guess you know that the angle of these two. I don't know if what I'm about to do is right, but I'm kind of curious just for my own understanding too, if this can get you to the right answer. So if you take the radius of that, r is equal to root 4a minus 6. This looks kind of horrible. Squared plus 3a plus 8 over 50 squared. Yeah, I'm not a fan of doing that. And then, I guess maybe what's more relevant though is pi over 4 equals arctan. This might be what you want. 4a minus 6 over 50 over 3a plus 8 over 50. So this could be it. Oh, I think this is what you want. Because now you take the tan of both sides. The 50s cancel. 4a minus 6 over 3a plus 8. Tan of pi over 4 is 1 for the same exact reason that I said here. So you get 1 equals 4a minus 6 over 3a plus 8. Multiply each side by 3a plus 8, and you're back where we were the last time. That matches that. So that's the general way to do this. And I'm glad that I figured that out, because that's helpful for me to know too. Ignore the R stuff. You don't want to go down that road. It doesn't help you. But yeah, if you're going to like a pi over 3 angle, I think you have to use this this way. I mean, I guess you could figure out a similar thing with the ratios between the x and the y, but that way it does the same exact thing with the ratios. So, okay. I hope that way makes sense too. What if the angle is something annoying like minus pi over 6? So if you're given non-unit circle, so actually your exact example, you could convert to something that's unit circle, I think. If you're given not unit circle at all, you're stuck with an ugly arctan, or an ugly tangent, I guess. Like, it's just going to be an answer that doesn't look nice. So, let's get something that's very obviously not unit circle, like minus, I guess I hope this isn't some weird thing, like minus pi over 17 or something. Arctan. 4a minus 6 over 3a plus 8. The only thing I can think to do here is you still take the tangent of each side. And you still solve for a, you're just going to have that really ugly tangent as part of your answer. Because it's still possible to solve this for a. You just can't evaluate that tangent. So you're gonna end up like, dividing by tangent minus pi over 17 and stuff like that. It's not nice, but you can do it. And I will say your specific example, you can say that minus pi over 6 is equal to, what would it be? Pi over 3 minus pi over 2. And do some fancy stuff with sum and addition identities for tangent. and you'll still get a unit circle thing out of that. But that's more like a trig thing. I assume you're not talking about like that exact thing where you can convert it into something that is unit circle. No problem, Henrik. I think complex variables are super fun, but I never took an actual class in them, so I can't always answer confidently, but what I've told you I think is the best that you can do. Messi, you. Thank you for the follow. You. Oh gosh, this is the answer, Anders? There's a whole fancy graph here. Let me just show my Discord, I guess. Okay, so Anders asked this question earlier about proving associativity of two sets given a certain definition for union. And I had the idea of the proof, but I apparently missed some steps here. So it's a diagram that may be useful. Oh okay. So if you want to prove associativity, you have to prove that this thing here is equal to this thing here. At school, you can do this in LaTeX. That's a DMU? Oh, okay. So your phone is a bit lagged? Okay, no worries. I'm not sure I say exactly where this